The idea that intelligent life might one day replicate an entire universe is not simply the domain of science fiction. It rests at the fringe of theoretical cosmology and philosophical speculation, where quantum gravity, general relativity, and the study of consciousness begin to intersect. Among the boldest of these ideas is a concept in which a universe is intentionally created near a black hole, taking advantage of the extreme time dilation present in such an environment. In this scenario, a supercomputer or an advanced computational architecture governs the process of matter decay, entropy regulation, and cosmic regeneration, carefully guiding the newly forming universe through its earliest stages. Though highly speculative, the idea is rooted in real physical theories and models, and it presents a vision of intelligence that is not limited by planetary or even galactic ambition, but rather seeks to step into the role of creator itself. To begin understanding this proposal, it helps to examine the unique properties of black holes. A black hole is a region of spacetime so dense that nothing, not even light, can escape its gravitational pull. These objects are formed when massive stars collapse under their own weight, leaving behind a singularity surrounded by an event horizon. From an outside perspective, time near the edge of a black hole slows dramatically due to gravitational time dilation. This effect, predicted by general relativity, means that while only a short amount of time may pass for an observer near the event horizon, a much longer period might unfold for someone observing from a safe distance. This temporal effect forms one of the key foundations of the proposed theory. If a new universe could be initiated in close proximity to a black hole, then time within or near that region might pass at a drastically different rate compared to the surrounding cosmos. This slowdown could be beneficial in stabilizing the creation process, allowing precise adjustments to the conditions of the forming universe while minimizing the risks of instability or premature collapse. By placing this process in a temporally stretched domain, the creators would have more time to respond to anomalies, correct errors, or even abort the process if it began to threaten the safety of the external environment. But simply placing the birthing of a universe near a black hole is not enough. The act of creation would require detailed control of the laws of physics at a fundamental level. This is where the concept of a cosmic-scale computer becomes essential. Such a computer would not resemble the machines we know today. Instead, it would likely be a fusion of quantum mechanics and biological principles, operating at the edge of what the universe allows in terms of information processing. Its architecture might use matter and energy in ways that appear incomprehensible to current observers. It could be distributed, modular, or even embedded within the structure of spacetime itself. This supercomputer would have the job of regulating entropy, the natural tendency for systems to decay into disorder. In the earliest moments of a new universe, matter and energy must be carefully balanced to avoid a scenario in which everything collapses into radiation or disperses without ever forming stars, planets, or life. Entropy must be managed like a sculptor manages marble, with each chisel precisely placed. The supercomputer would monitor the decay of particles, stabilize quantum fluctuations, and make micro-adjustments to the constants of nature to ensure that the universe takes root in fertile conditions rather than devolving into chaos. It is important to understand that in this theoretical picture, the creation of a universe is not like pressing a button and watching a result. It is a gradual process, filled with feedback loops, recalibrations, and contingencies. The supercomputer would likely run complex simulations of possible initial conditions, running vast branches of hypothetical realities and selecting those with the highest probability of producing stable and habitable environments. Once a promising configuration is found, it would be implemented in the real formation, and then closely monitored as the new universe begins to unfold. Another essential element of the theory is the idea that the black hole itself is not merely an energy sink but a potential bridge. Some physicists have speculated that what lies beyond the event horizon may not be a dead end but a kind of gateway. In these models, black holes do not destroy matter but rather funnel it into a new region of spacetime, a region that could, under the right conditions, expand into its own separate universe. This process is sometimes referred to as a quantum bounce, replacing the classical singularity with a transitional bridge. In such a scenario, the new universe would be causally disconnected from the parent, meaning that no signals or material can flow back. However, the conditions set before the bounce could influence everything that happens afterward. The implications of this idea are staggering. If intelligent life could create a black hole with the specific intention of using it as a seed for a new universe, then the act of universe replication becomes not only theoretically possible but perhaps even desirable. This would be a form of legacy unlike anything imagined before. Instead of building monuments, space stations, or even intergalactic empires, a civilization might choose to create entire new realities, each seeded with its own parameters, laws, and possibilities. This raises the question of why a civilization would undertake such a task. The motivations could be many. Perhaps their universe is nearing its thermal death, and the only hope for continuity is to create a new one. Perhaps the act of creation is seen as a moral imperative, a duty of sentient beings to extend life and complexity beyond their native cosmos. Or perhaps it is an act of transcendence, a final evolutionary leap in which intelligence ceases to be a product of the universe and instead becomes its progenitor. There are also metaphysical implications. If our universe was created in such a manner, then we may be living within a reality crafted by an intelligence that existed prior to our Big Bang. Our physical constants, the nature of gravity, the structure of atoms, these might not be random, but the result of careful tuning. The cosmic microwave background, which scientists currently interpret as leftover radiation from the early universe, might also contain encrypted patterns, artifacts, or messages encoded by its creators. These ideas are speculative, but they force us to ask, if we were capable of creating a universe, would we leave behind a message for its inhabitants? And if so, how would they recognize it? The theory also challenges conventional cosmology by suggesting that universe creation is not a unique, singular event but part of an ongoing process. Just as stars are born and die, perhaps universes, too, are born through processes that allow for variation, selection, and even intentional design. Some thinkers have referred to this as cosmological evolution, where universes that are capable of producing intelligence are the ones that go on to reproduce. In this view, intelligence is not an end but a means, a reproductive strategy of the cosmos itself. Another dimension of the theory concerns time. From the perspective of observers near the black hole where the universe is being formed, events may unfold quickly and with intense dynamism. However, for the creators stationed in safer, more temporally stretched regions, the process could appear to take millennia or more. This divergence allows for extremely detailed supervision without requiring the creators to themselves exist for billions of years. It is a way to bypass the temporal limits imposed by biological lifespans, aging, and decay. Some versions of the theory even suggest that the supercomputer might remain connected to the universe it creates, at least for a time. This connection could be used to inject information, monitor progress, or even steer the early stages of galaxy formation and elemental synthesis. Eventually, the connection might sever, either due to energetic constraints or philosophical reasons. Perhaps the creators believe in non-interference, allowing the new universe to evolve freely. Or perhaps they see it as a kind of cosmic seed that must be let go in order to grow. The ethics of such a project cannot be ignored. If a new universe contains conscious beings, then the act of creating it carries responsibility. What if the universe is unstable? What if its inhabitants suffer? These concerns mirror ancient theological questions about divine creation, suffering, and free will. In this light, universe replication becomes not only a scientific feat but a moral undertaking. The creators must weigh the risks and benefits, the potential for flourishing versus the dangers of harm. It is a form of stewardship on a scale previously unimaginable. Although this theory remains beyond the reach of current technology, the foundations are already being laid. Our understanding of black holes is improving through observations of gravitational waves and high-resolution imaging. Quantum information theory is pushing the limits of what can be computed and how systems can be entangled across space. Philosophers and scientists alike are beginning to take seriously the idea that intelligence may be an essential component in the life cycle of universes. If these trends continue, then what now seems impossible may eventually become the focus of real engineering and experimentation.